As promised, here's my video for Lab 18, which we didn't get to in our online meeting this week. So, two main topics in this in these sections, right? The first one is sets of numbers. So you're dealing with rational, irrational, whole, counting, and integers. And then you're dealing with averages, measures of central tendency, namely mean, median, and mode. So first thing is number 1, 2 to 3, they want you to basically write these numbers as fractions with integers in the numerator and denominator. And the reason that you would do that is once you've done that, you're basically showing that they are rational numbers. So like the first one is obvious. Okay, it's really just turning a mixed number into an improper fraction. So you do the 7 times 2 plus 1. Remember that wheel thing you do. So you end up doing 7 times 2 plus 1 is 15, and then you leave it over the same denominator of 7. So it's 15 sevenths. So now you showed that that is rational by writing it as a fraction with integer, numerator, and denominator. Now number 2, you have a couple of options. Well, not really. I mean, you can reduce it or you don't have to reduce it because they don't necessarily say that you have to reduce it. But what you can do with this is negative 4 and 52 hundredths. That's the way that you basically want to think of it, right? You don't want to think of it as negative 4.52. You want to think of it as negative 4 and 52 hundredths, because then you could basically write it just like we just wrote the other one, right? Negative 4 and 52 hundredths. But then what's going to happen with this? When you do the whole multiplying and adding thing, 100 times 4 is 400 plus 52 is 452 over 100, and then you just bring the negative sign down. So now you've written it as a fraction with integer, numerator, and denominator. Now, could this reduce? Yeah, it could, but you don't even necessarily have to reduce it. They're not telling you to. They're just saying write it as a fraction with integer, numerator, and denominator. And now that's done. All right, and then negative 11, you should remember that any integer you can always just write as that integer over 1. Okay, because you're thinking of this as negative 11 firsts, basically, right? Each whole is just one piece, and you have 11 of them. Well, technically it's negative 11, but that's the idea. So any integer, you just write over 1, and then that's it. All right, so now this is the whole idea of classifying, right? Classifying the numbers. So negative 8, is that a whole number? No, because whole numbers started at 0, didn't contain any negatives. But is it an integer? Yes, it is. Is it a rational number? Yes, because you can write it as negative 8 over 1. So if it's rational, it can't be irrational. And then 11 ninths, well, is that a whole number? No. Is it an integer? No. But is it a rational number? Yes, because it's written as a fraction with integer, numerator, denominator. And then since it's rational, it can't be irrational. All right, now 4 is the first one that you have this linking effect, right? So 4 is a whole number, which means that it's also an integer, right? Because any whole number is also an integer, which also means that it's rational, because any integer is also rational. So the minute you check whole, you automatically have to check integer and rational. Just like with the first one, the minute we checked integer, you also had to check rational. Now 11 ninths was only rational because it's not an integer or a whole number. All right, and then 8.8 is similar to 11 ninths. It's not a whole number or an integer, but it is rational because it's a terminating decimal, right? Any terminating decimal or repeating decimal is rational, and therefore it's not irrational. Square root of 81 is actually equal to 9, so it's actually just like 4, where it's just whole, integer, and rational. Square root of 15, however, no, right? Square root of 15 is 4, I'm sorry, it's 3 point something, right? But it has no repeating pattern and it never ends, right? The problem with this calculator is I think if I do square root of 15 on this, it's going to leave it as square root of 15. Yeah, I think if you want to get it, maybe you can do classic mode and then re-enter it. And if I do classic mode and re-enter it, yeah, now you can see there's no repeating pattern there and it's never going to end. Therefore, it is irrational. And then 0.9 repeating, right? Remember that was something for rational numbers. A rational number is either a terminating decimal or a repeating decimal. So this decimal never ends, 0.9 repeating, but it does have a pattern, therefore it's a rational number. And then 2 pi, well, pi was was an irrational number, right? It's approximately 3.14, but it never ends and goes on forever, right? So it goes on forever and it has no repeating pattern. So 2 times that is going to be the same. So it's going to be an irrational number. So that's your sets of numbers business. The remaining 3 problems deal with measures of central tendency: mean, median, and mode. So the first one is a group of 7 friends discussing parking tickets. The number of tickets each received was 2, 3, 2, 4, 2, 4, and 18. So one person has a lot, right? 18 is a lot. So the mean, if you remember, it was the sum of all the values divided by how many values there were. So when I add all these up, right? Because remember, again, I'm going to write this sum of all the x's, right? And these are the different x's. So when I add them all up, 2, 5, 7, 11, 13, 17, and 18 is 35. So it's 35, and it was 7 friends. So it's 7 different numbers here. So when you do 35 divided by 7, it actually comes out to exactly 5. So the mean number of parking tickets is 5. And then the median, now with the median, you remember, and well, and the mode, it's probably easiest to do this. You want to arrange them in order from least to greatest or greatest to least. So if I wrote these out in order, I would have 2, 2, 2. There were 3 2's, right? Then 3, 4, 4, 18. Is that all of them? Yeah, that's 7 numbers. Okay. And then when you were dealing with an odd number like this, 1, 2, 3, 4, 5, 6, 7, there is actually a middle number. And in this case, the middle number is 3. So the median, because remember, it's the one in the middle, it's actually 3. And you remember the mode was, of course, the one that appeared the most frequently. And there's 3 2's. So the mode is going to be 2. So the mean is 5, the median is 3, and the mode is 2. And then number 6 is very similar. Okay, you survey another group now of 6 students to find out how many tickets they received, and there's the numbers. So again, the mean is going to be the sum of these values divided by how many there are. In this case, there's 6. And when I add them up, 2 plus 3 is 5, 9, 12, 14, 18. I get 18 over 6, which is just 3. So the mean is 3. The median now, if I arrange these in order, I have 2, 2, 3, 3, 4, and 4. So there is no middle here, right? There's no exact middle. So when there's no exact middle, what you do is you take the 2 that are closest to the middle, in this case the 3 and the 3, and take the mean of these. But if they're both 3, the mean is still going to be 3, right? I mean, I do 3 plus 3 divided by 2, and I get 6 over 2, and I get 3. So the median is 3, right? If the two numbers closest to the middle are the same thing, then the median is just going to be that same thing, because that's the mean of the same two numbers is itself. So, and then the mode in this case is weird because everything appears twice. So there's actually 3 modes: 2, 3, and 4. That's what you would call trimodal. There's 3 different modes. So the mode doesn't really tell you much, because there's 3 different ones. And then the idea about D is the big difference occurs, of course, in the mean. The mean in number 5 is way larger. And the reason that it's way larger, because someone had, what was it, 18, I think? 18 tickets. So everything else was fairly close, right? The median was 3 here, and in the other one we did, it was also 3. The mode was 2 there. Here, the mode was just 2, 3, and 4. The big difference, of course, occurred in the mean. Here, the mean was 5, because that person had 18 tickets, and then here the mean was 3. Okay, so that's the idea. And then this grade point average business, this is how you calculate a grade point average. What you basically do is you multiply the number of credits you have in a specific course by what's called the points per credit of that grade you got. So a B minus equates to 2.67 points per credit. And then a C equates to 2 points per credit. A C plus is 2.33 points per credit, and A minus is a 3.67 points per credit. So what ends up happening is like an A is 4 points per credit, right? You can see the whole scale here. So then that's why they say if you have a 4.0 GPA, that's a perfect GPA. Why? Because you got an A in every single course that you had, right? So if you have a GPA like a 3.3, that's roughly a B plus. So your grades average out to about a B plus, so on and so forth. So what you do in this is you multiply as you go across. So here you do 2.67 times 4, and that's going to give you 10.68. Then you do 2 times 3, that's just 6. Then you do 2.33 times 3, that's going to be 6.99. And then you do 3.67 times 4, that's going to give you 14.68. So these are all your grade points. So for the one class, you get 10.68 grade points. For this class, you get 6 grade points. So on. You add up all these grade points, you get 38.35. 38.35. And your total credits is 4 plus 3 plus 3 plus 4. That's 14 credits. And then your GPA then is just going to be the grade points divided by the number of credits. So it's 38.35 divided by 14, and that's going to be 2.7, and I'll round it to 2.74. Usually you go to 2 decimal places in these. So this is 2.74. So this is the semester GPA for this person is a 2.74.